Okay, maybe you picked 5-3 for practice. So this is extra practice using radical and exponent rules, and we want things in radical form. All right, so if I've got 6 fourth roots of 2, and I'm adding to 3 4 roots of 2, that's going to be 9 fourth roots of 2. Of course, they're not all going to be that easy. All right, when I break down 250, I know that breaks down into 25 and 10. So I get 5 times the square root of 10. 160 is 16 times 10 minus 4 square roots of 10. That gives me 1 square root of 10. All right, cube roots. When I look here, I've got 9 times the cube root. When I look at 250, I know that's 5 times 5. There's my 25. Times 5 times 2. So that's 9 times 5 times the cube root of 2. We can simplify this one. Minus 7 times the cube root. When I look at 54, I know 54 is 9, which is 3 times 3, times 6, which is 3 times 2. So I can simplify that. Here's my 7, that was my coefficient. These 3 3's come out as 1, and I'm left with the cube root of 2, which gives me 45 cube roots of 2 minus 21 cube roots of 2. That sounds to me like 24 cube roots of 2. See how they get a little harder each time. Alright, so now we've got exponents and radicals together. When I have an 8th root of x to the 4th and x to the 4th, that same base add, 8th root of x to the 8th, that's just going to be good old x. When I have here, I need to make sure, and I don't need a plus minus here because there's no equal sign. I'm not solving yet. Okay, when I take the square root of my negatives, don't forget that I comes out. So the square root of negative 16 is 4i. Square root of negative 5 is I times the square root of 5. I times I is negative 1. So negative 4 times the square root of 5 is my final answer. Alright, my radicals, my indexes match, and I don't have any negatives, so I can put everything under one radical sign. I can say 7 times 2 is 14, and then under the radical sign is a 3 and a 6, and 3 x's and 3 y's. This 6 is a 3 times 2. Here's my double factor. So 14 times 3 comes out, and this 2 is left inside. 2 x's come out as 1, and 1 is left inside. 2 y's come out as 1, and 1 is left inside. 14 times 3 is 42. 42xy times the square root of 2xy. Alright, number 7. We can go ahead and put all this under one radical sign. So I can go ahead and have 54 x to the 3rd, or x to the 5th, y to the 3rd, over 2x squared y. When I go to simplify this fraction, 54 divided by 2 is 27. X to the 5th, same base subtract, gives me 3 x's. Same base subtract gives me 2 y's. And don't forget, I'm taking the square root. 27 is 9 and 3. Here's a perfect square. He comes out as 3. And this 3 is stuck inside. 2 x's come out as 1, and 1 is inside, and 2 y's come out as 1, none left over. This negative exponent wants to be up here with its friends, so I want to find the square root of x to the 9th, because it's same base add, y to the 5th. 8 x's come out in 4 groups of 2, with 1 left inside, and my y's come out in 2 groups of 2, with 1 left inside. Alright, 343, is that the friendly number I keep forgetting? So when I go to my calculator, if you look at the last number I used, yep, that's my 7 cubed. That's the one that I never seem to remember. So the cube root of 64 x to the 11th over the cube root of 343 x squared. Ooh, wait. I think I want to simplify these x's first. We'll call the same base subtract. And we'll call this 9 x's, and we'll say that those x's were simplified. I like that better. Cube root of 64 is 4. Cube root of x to the 9th power is going to be 3 groups of 3. And there's my 7. Worked out nice and neatly. Alright, next page. The 4th root of 512. If I'm not familiar with 512, let's check out that number and see what kind of factors he holds. When I look at, oh, that's 8 and 64. So I've got a lot of 2's in that. 8 and 64. And this is 8 and 8. Remember, I'm looking for 4 factors to come out evenly. I know 81 is 3 to the 4th, so that's going to simplify. Let's see what's up with my 8's and 2's and 4's. Here's 1, 2. Oh, I did it again. There's 1, 2, 3 4's, and here is 1, 2, 3 2's. Oh, this is going to be fun. 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So when I take the 4th root of 512 over the 4th root of 81, my denominator's 3. I was sure of that. Let's see how many groups of 4 2's can come out. Here's 1, 2, 3, 4. That's one group. Here's 1, 2, 3, 4. That's 2 groups. So 2 groups come out, and 1, 2 is left inside. Alright, so we have the square root of 3x over the square root of 7y to the 16th. These 8 y's can come out. Square root of 3x over my 8 y's and my root 7. Not allowed to have this in the denominator. So square root of 7 times the square root of 7 will help me rationalize it, giving me the square root of 21x. 3 times 7 is 21. I can put these under the same radical. Here's my 8 y's, and then root 7 times root 7 is 7. He's out there as a coefficient. Do not even begin to think about canceling these out. This is the square root of 21. Definitely not a friendly number with 7. Alright, number 12. Cube root of 5x times 5x. That's going to give me, I can't do it. My radicals don't match. So this is going to be 5x to the 1/3 power times 5x to the 1/2 power. If I want to go ahead and multiply these, I need to make my denominators match. 5x to the 2/6 power, 5x to the 3/6 power, which is going to give me 5x to the 5/6 power, which means I want the 6th root of 5x to the 5th power. This is a star. Come ask me if you want me to explain that one a little more to you. Okay, simplify each of the following expressions using exponent rules. Here's a review of day 2 notes. Put answers into simplified exponential form. All right, we're going to share this out to each factor. So that makes m squared times m to the -4th times n to the 10/3 power. Same base add is going to give me m to the -2, n to the 10/3. So n to the 10/3 stays up, m squared goes down. Holy cats. All right, let's take a look at this one. My 3's are not a part of this exponent at all. So 3 times 3 is 9. Same base add, -1/2 plus +1/2 is 0. X to the 0 power is equal to 1, so he goes away. This is going to be moving to the denominator, y to the 1/3 power. This is going to stay here. I'm going to eventually cancel that out, and this negative brings him up to the 7/4 power. Same base, subtract. So these cancel out to 3. And then I have y to the 7/4 minus y to the 1/3. So when I put this into 12ths, this makes 21/12 times 3 times 3. Put this into 12ths and I have 4/12. So I wind up with 3 times y, 17 minus, or 21 minus 4 is 17/12 power. All right, power of a power, very powerful. So I'm going to go ahead and multiply. These 3's cancel out, so I end up with x to the -2. I'm going to be moving him down, or maybe not. This 2 stays, and this x comes up here. So 4 minus 2, I'm doing same base add. 4 minus 2 is 2, plus 2 more is 5. So we end up with x to the 5th over 2. This 25 is not affected by the power. It's just the r. To the -1/2 means that we move that down to the denominator. Anything to the 0 power is 1. So this becomes 2 to the -3 times y to the -6 times 2x cubed y. So let's see, 2 to the -2 times 2 to the first, same base add, becomes 2 to the -2nd, and that goes down in the denominator. Same base add, -6 plus +1 is -5, down he goes, and x to the 3rd is fine. Here, if it's a friendly number, go ahead and simplify 2 squared. All right, this exponent applies to everything. So we're going to go ahead and just move my 2 to the 4th and my x to the 4th to the denominator. My x to the 1/3 comes up. This x stays down here. He's got a positive exponent. He's good where he is. So that's going to give me x to the 1/3 over 2 to the 4th is 16, x to the 5th. This has to be simplified. So it's x to the 1/3 minus 5 power over 16. So 1/3 minus 5, if I put this into thirds, 5 is 15 thirds. So that means I get x to the negative 14 thirds power over 16. Guess what? He's going back down to the denominator. So my 1 holds my spot in my numerator. 16 times x to the 14 thirds power. How'd you do?